So if we have a problem like this, a fraction that we need to split into two fractions, do the partial fraction decomposition, what you have to look at, and I haven't said this yet, you have to look at the denominator and look at the factors in the denominator. If the factors are linear, what does that mean, linear? Raised to the first power. If the factors are linear, then it's going to be the type of problem I've been doing. It would be a over 1 plus 2x plus b over 3 minus x. And on this problem, that's all they wanted. Write it out, the very first step you would do for partial fraction decomposition, and the direction said do not determine what a and b are. Do not determine the numerical coefficients. And for 1b, I have this. 1 minus x over x cubed plus x to the fourth. So your job, if the denominator is not factored, you've got to factor it. How do I factor this denominator? Take out the x cubed. So it's going to be 1 minus x over x cubed times 1 plus x. Now this one may be a little bit confusing because there's probably two ways I could proceed with saying what I'm going to say. I'm going to go this way with it. I have x cubed in the bottom. That is not linear. If you have something that's not linear, it's a different story. So what I would do for this one, I would say a over x to the first plus b over x squared plus c over x cubed. For this part that's not linear, I'm going to start with x to the first, and I'm going to increase the exponent until I get to whatever exponent's in the problem. And then the 1 plus x, that is linear. So that one's going to be plus d over 1 plus x. Okay, I'm going to do a few more of these so you can kind of get the idea of what's going on with them. Here's another one. This is actually number 5b. 5b. So I have x to the fourth in the top over x squared minus x plus 1, x squared minus x plus 1, times, open parentheses, x squared plus 2, and that is raised to the second power. For this problem, can you factor x squared minus x plus 1? Not when the coefficients are from the real numbers. So in terms of what you learned in algebra, this is prime. Now, that means this first factor is not linear. So that's a different story when you're doing partial fraction decomposition. I would do this. The first fraction is x squared minus x plus 1. So something over that. The numerator is going to be ax plus b. Whatever the degree is in the denominator, in this case it's a 2, then the top is going to be 1 less than that. So a times x to the first plus some number b. And then the other part, I'm looking at the x squared plus 2 that's in parentheses. Can you factor that? No. You got the same thing going on right there. So I'm going to move to the next letter in the alphabet, C. That'll be cx plus d over x squared plus 2. Now, just like on that last one where I did 1b, I had that x cubed, I did x to the first, x to the second, x to the third. You see that exponent, that 2 on the outside? That happens right here. So this is x squared plus 2 to the first, plus, I got to increase that exponent on the outside until I reach a 2, and there it is. I'll reach it right there. And so this is going to be ex plus f. And I would solve for those A, B, C, D, E, F. Now again, the book right here, these problems are just practicing what that first step would be when you're doing partial fraction decomposition. They said do not do the partial fraction decomposition. Do not solve for the coefficients in this problem.